Good morning, everyone. Is my voice audible?
Good morning, sir. Yes, sir, you're audible.
All right, let me share my screen. We'll start the class. Can you able to see my screen?
Yes, sir.
So we'll wait. We'll just wait 1 or 2 minutes so other friends can join. We'll start the class. Okay.
Yes, sir, I have a request.
Yes.
Sir, most of the students are busy in traveling, and most of the students already have visited the hostel for their hostel allotment process. So that's why I think not more students can join for this class.
Okay. But the classes were supposed to start last week. Already 1 week we are behind, right?
Yes, sir.
So it's okay. This week is very fundamental. Even if students don't attend the class and they can go through the slides, still will be able to understand.
Yes, sir.
So today we will not cover in depth. We'll just cover the basics only. Just we'll brush up our brief knowledge about computers. So today the class is about basics of computers only. Just we'll discuss few aspects of computers, and many of you would are aware of many of these things. But as the course says, data structures and operating systems. Before discussing that, I mean, like before directly jumping into the course curriculum, let us have a brief understanding. If people coming from rural background, if they don't have any idea about what is computer and what are actual input devices or output devices, uh, then what are the various aspects in the computer, perhaps that knowledge one must have in order to understand the course of operating systems. So it's okay. Even though students are very less, still it's worth not to wait. So how many are there now? 21 are there.
Excuse me, sir.
Yes.
This is for ECB.
Yes, this is for ECB.
Okay, sir.
This is for ECB. ECA I will take from 12 to 1. Shall we start now?
Yes, sir.
So this is your curriculum which has been given in your uh, the website of MNIT. So these are the 5 units we are going to cover. So we'll start with basics of computer architecture. So this is your unit 1, basics of computer architecture. What is the functional structure of hardware software components? What is CPU, ALU, memory, IO devices? What is system software, application software? These are the few things that covers unit 1. Predominantly we will try to understand what they are first in today's class. Okay, then subsequently we will discuss what is the role of operating system, what is the main motivation for studying this course, or history of hardware. So everything we'll discuss subsequently. Then unit 3 is about programming software, how to write a software program process, and how we can define the time and space complexity. All these things also we'll discuss. Simultaneously we'll discuss, see, the unit 4 is given as data structures, linear and non-linear data structures, stack view, tree, graph, B trees. However, your assignments will be predominantly emphasizing on data structures only. The curriculum what has been given for your lab is entirely depending on data structures. So the data structures, the assignments will be purely based on data structures. But few concepts I asked the guest faculty to discuss before they you can implement it easily. If maybe one or two class afterwards, we will see if possible we can discuss data structures first, so that it will help in your assignments. Then subsequently we can discuss operating systems that we have to decide. We will see that how these things will work out. If you are comfortable in implementing the programs and the assignments that has been given in your labs, then we can discuss that later also. Or else, if you are facing very difficulties, not able to understand, then we can discuss these concepts of data structures first. That will help you in your implementation. Then we can subsequently cover operating system concepts. As you wish, you start working on your assignments, and I'll ask the guest faculty to get the feedback. And after getting feedback, we will decide how we'll proceed further. So these are the few things that I'd like to convey. And the fifth unit is very important. Processor memory management, the semaphores, preemptive, non-preemptive scheduling. This all will be predominantly important. One should aware of operating systems. So these are the few textbooks that has been suggested for you. Fundamentals of Data Structures by Horowitz and Sahani, and Data Structures by Tenenbaum, on Operating Systems by Abraham Silverskas and Peter Gallin. This is a very important book. If you have a habit of buying textbooks, you should have this book in your library. Okay, this is very important book, Operating System Concepts. The recent version, you can buy the 10th edition. You can ask that if you are buying 10th edition, would be the recent one, which covers the various operating system concepts which we are using currently. Okay. When I studied operating systems way back in 2007 to 11, at that time also this textbook was the predominantly suggested by many faculties, and the same book I studied. But in this 10 years, the way operating systems evolved is dramatically exponential, in the sense like at that time the operating systems predominantly what we are using was Windows XP, Windows Vista. Those were the operating systems famous at that time. But operating systems has been developed exhaustively nowadays. We have Android operating system, RTOS, real-time operating system, iOS, Windows 10. I mean, like Linux. So many advanced versions came. So this 10th edition of operating system concepts will cover all those concepts. That's why I'm asking you to buy the recent edition. If you buy the old edition, you may not get the concepts of the recent recent updates that have been happened in this field. So these are the few textbooks you can get through or go through them. So we'll try to take all these courses, all these concepts for this course. So there is nothing much to focus on this slide. This for your brief idea that what we are going to study in this course is what I'm like to bring to your notice before starting the class. And you can keep checking your curriculum whether we are going or covering all the concepts, whether we missed or not. We'll discuss them. Okay. So let's start with the basics of computer, like what has been given, like basics of computer architecture. We'll try to see what is the hardware and software components, what is actually memory IO units, what actually they are. We'll try to see in today's class. So we'll try to cover few concepts in unit 1. So there are various categories of computer. Usually when we say computer, we can immediately the thing might strike in our mind is like desktop PC or laptop. But nowadays, whatever we can do in laptop, we can carry out in smartphone and tablet as well, right? So we call that as a mobile computer. So this is predominantly one person can use. A single personal computer. Laptop will be carried out by a single person, or tablet or smartphone. It will be controlled or used by a single person. So predominantly, we can make calls in laptop also using now. Now we are meeting in MS Teams. I don't know how many of you are joined through mobile, how many of you joined through tablet, how many of you joined through laptop. I'm using my personal computer to take the class, but on the other side, many of you might have joined through laptop or phone or through tablet. So that's how today's the idea of computer has been evolved, right? But if you come to other idea, microcomputer, so we have desktop also, we have workstation. Workstation, you'll have better features, you'll have good storage, big process speed, uh, and higher process speed, and you have good way of taking the things. The functionality will be better in workstation. So we call this category as microcomputer, and we can also call mainframe computers. In mainframe computers, the servers are loaded with. We can see that it will look like this. If you would have observed in our, I don't know, you are just coming to college. Perhaps if in your first year, you will be asked to go to college computer center. On the ground floor, you can see all these mainframe computers. So it's not a single computer, but you connect a lot of processors, a lot of memory. This will be taking more thoroughly. For example, I want to provide a future for the entire college, your college admissions, processing. It will take like in our college, maybe 4,000, 6,000 students will be there. And if they ask you to do the registration, everyone will come on a single day. The process should be able to handle the huge amount of data, right? So all these things you cannot carry out in a single computer. You need a big sophisticated thing that can carry out. So mainly like in colleges or in some working places, mainframe computers has been predominantly used. And beyond that, there is a supercomputer. Supercomputer, you would have heard. It's like the movies, like how you can Avatar, Titanic, all these movies. You need a lot of graphics. The graphics that has been incorporated in such movies, you cannot simply process. They'll take with HD quality, and they do a lot of graphics inside that movie, right? It will look like as if it is real. So such kind of huge movies will take huge amount of data, maybe to 2000 to the movie what we can download, maybe if you get a good quality 1 GB to 2 GB. But when the movie actually, if you with the HD quality, you try to capture them and try to make a movie with actual without compression, then the movie would be nearly not less than 50 GB or 100 GB. So such kind of graphics will be there, and you want to process them, and you want to carry out many of such movies they made from supercomputers. Okay, and they will compress that movie to 2 GB or 1 GB, even though the it won't look like the clarity is missing, but still you'll be able to watch the movies. So supercomputer is more powerful in terms of computation, in terms of speed, in terms of various aspects. So what do you mean by speed? What do you mean by storage? If I have to process them, all these things, I'll discuss this later. But these are the various categories that I will bring to your notice. If you're not aware, you should get aware of that. Okay, so you have personal computers, that what we are using, like mobile computers. Uh, you have again the workstations and mainframe computers and supercomputers. These are the various categories of computers. But in all these computers, we can classify a computer into two categories. One is hardware and software. So we are going to discuss. We'll see predominantly what is hardware for a few minutes. Then we will try to see what actually the software is of. Okay. So hardware, when I say, it's a system unit we will try to understand from a personal computer point of view, like you have on your desktop. I'm not talking about laptop. I'm talking about the second aspect, like microcomputer. We'll try to see from a microcomputer perspective. Uh, then predominantly, more or less, with a compact size, you can try to realize in excuse me, you can realize in laptops and other devices as well. We'll try to see from microcomputers point of view what is actually hardware. So if you see from micro computer point of view, we have for that matter any this, when I say a computer parts hardware or software, it will be applicable for all computers, but for better understanding, we will try to see from microcomputers point of view. So hardware means you have a system unit, you have input devices, you have output devices, you have storage devices. When I say software, we have an operating system, we have application software and utility software. They are all different. We'll try to see what is the difference between operating system and application software. We'll try to see what is the difference among them. We'll also try to see what is the difference between all this storage devices or output devices, input devices, what they actually are. Also, we'll try to understand. So when you open a system unit, it will look like this. Okay. So what do you mean by that? So when I say this is the box, what has been shown here, say Dell or this guy, HP. This is called the system unit. Okay, when you open this, you have a space here, or you can open either side of that. Once you open, it will look more or less like this. Okay, when you open and look inside that, more or less it will look like this. So you have a power supply unit, you will connect a power supply, you have power cables, you have fan, we have processor here, CPU, fan, we have input output devices, you can insert RAM slots, random access memory slots, you got another board, you got battery here, you got this entire board is called motherboard. Okay, and you got data cables like we'll connect from the hard disk to your processor, or from CD-ROM to the processor, all these things. Okay, this is a case. I mean, like the cover which encompasses all these things is called case. You have a hard disk, you will keep the hard disk, you will get the power supply, and the data cable will be connected to your motherboard, and you got floppy disk drive, data cable, so on and so forth. So these all hardware components, we call that as a system unit. Okay, so everything will keep inside a box which is called as a case. Okay, so what is actually this CD-ROM, what is actually this flop disk, what is actually this hard disk, what actually is motherboard, what actually is input output, what actually is RAM, we will try to see in the subsequent slides. But when you open your system unit, more or less it will look like this. You might get confused, but we'll try to understand one at a time so that it will bring you some amount of clarity. Okay, so in system unit, you got motherboard, you got processor, you got RAM, you got case, power supply, floppy drive, and hard drive, CD drive or DVD drive, video card, sound card, modem, everything. All this hardware parts will come under system unit. So this is called a case. Okay, this is the machine Dell which I am using right now to present your class. So this will look like a box which will keep all this motherboard, power supply, everything inside this box. This is called a case. This is a frame that houses all these things. Okay, motherboard, power supply, disk drives, adapters, just a box. Okay, just a box, we call that as a case. So inside the case we'll keep motherboard. A motherboard will look like this. So this is the processor where you'll keep the processor. This is also called main board or a system board or a planner. Okay, this is also called a main board, system board, or a planner. This is a processor, and this is where you keep RAM slots. I will also show you on the next slide how a RAM will look like. So this is a simple idea of how the motherboard will look like. You got your USB ports, LAN ports. You can connect the power supply here, so on and so forth. On top of that, you got a fan that will cool the processor. Okay, so mother. Any questions? So motherboard is the one which connects all the components inside the computer case. Okay. So in motherboard you will get, because the processor, RAM, all the other parameters will get connected to the motherboard. Okay. So this is one thing, and the second one important thing is processor. So processor is also a thought of brain or an engine of a computer. If someone has any issues, why I'm hearing voices? So a processor, initially when it developed a computer, it was very large, but you can see the size that has been compacted because of VLSI, very large integrated circuits, that we are going to study as a course, I believe, right? So I no need to teach for the electronic students what is a processor, but still, for your just understanding, you got two types of processors predominantly used in the market. One is Intel and AMD. Okay, so the recent version is i9. i9 also came into the market, but nowadays i7 has been used by many people. i9 also came. We'll also see in the subsequent classes what is i3, what is i5, what is i7, what actually they are, what is the difference between them. Also, we'll try to understand in the subsequent classes. So when I say processor, this is where each and every instruction will execute. This is also called the brain or the computer engine or computer brain, where we also call that as a central processing unit. Okay, we call that as a central processing unit. Inside this processor, you will have arithmetic logic unit, control unit, all these things. We will try to understand that as well. So processor is the main brain or engine of a computer. Okay. So this is a memory, RAM. RAM will look like this, shown in the slide. So this is also called as random access memory. The system memory is where before and when you write a code, that code will be, you have written in the first year C programming, right? In C programming, you have written a number of lines of the code. Those are called set of instructions, correct? You write set of instructions and you execute them and you will get an output. So the code what you developed, what you wrote, will be first fetched from your computer. You save that. It will be stored in your hard disk or somewhere wherever you store. That will be stored in your computer and it will be fetched from there to RAM. From RAM, it will go to processor for execution. So this is the primary memory which holds all the programs and data and the processor is using at a given time. So the processor will collect the instructions from RAM. So depends on your RAM space. If your RAM is more, then the speed will be increased. If RAM is less, then what happens is, because of RAM is very less, you have to keep swapping the instructions from secondary space to the RAM and keep, so that will take some time. So that's why your system will be slow. Few things I will say from the computer's point of view, but if you're not able to understand at any point, please stop me and ask questions so that I'll be able to explain in detail. Okay. So processor is where the instructions are executed. Secondary storage or hard disk is where you store your file. So if a processor wants to execute an instruction, it will fetch your code from secondary storage, that is hard disk to RAM. So it will collect all your instructions from RAM to process. The processor will execute the instructions by collecting them from RAM. Okay. So random access memory is a volatile. Volatile means if the power goes off, you will not have any memory that will be having backup. So that's why your secondary storage will be, once you save, it will be stored in secondary storage. Even your power goes off, it will be there, the files will be there. It's a non-volatile, but RAM is a volatile memory. Once your file power goes off, everything will become zero, so there will be nothing in the RAM, so you have to restart everything. Okay, so this is a simple, but and hardware, if you see from hardware perspective, it will look like this. So it's looking like a scale. This is one RAM, this is another RAM. There are two RAMs here. Okay, there is a space here. So this inside this, you can see the golden lines will be inserted in the motherboard. This is a RAM slot, so you can insert in the motherboard here. So that will be you can insert and plug it. Okay, so the RAM will be connected to the motherboard, and the processor will take instructions from RAM, and the secondary storage will also get connected. I will show you how things will look like. Okay, so this is simple power supply. Once we need to start a computer, we need current, we need power. So the electric power supply board will look like this. So you got fan to cool this, and you can connect here. So outside it will come just as a looking like as shown in the slide, but you can easily connect to that. So a CD or DVD drive is another component in the system unit, where you can store your data. Nowadays, CD DVD drive are coming with high capacity, which is a removable media, which is an optical drives. So most systems include readable, read-writable CD DVD RAM, readable writable DVDs, which is a combined one, right? So perhaps you would have saw that, but mostly many of you would have not used that, because nowadays many of people are using flash drives. That also I will show in the subsequent slides. So this one unit in the system, this is one component in the system unit. If you have DVD drives, you can also have that. So you have a hard drive. This is internal hard drive. So hard disk. If you say hard disk, it can be external or internal, but it's a hard drive. Like primarily, I'm talking about internal hard drive. You will connect. You can see here in the slide, you can keep hard disk here. So you will get power cable and data cable that will be connected to your motherboard. So this hard disk you'll get maybe it's not clearly visible, but you will get two cables will be attached to that. One is data cable and other one is power cable. So the power cable will give you the power for the data to store and read and write. And likewise, once you fetch the data will be fetched from this hard disk, and it will be stored in RAM to go to processor for execution. So this is an internal hard disk. You can see Seagate is a good company of hard disk. You can see this 1000 GB means 1 TB hard disk. Okay, so where you store, this is also called secondary memory. So this is a non-volatile memory. Even the power goes off, still you'll be able to fetch the data again and again, right? So once your operating system, operating system and the files, everything you store in hard disk. Once you turn on the power, all these details will be fetched from hard disk to RAM, and RAM to processor, and the processor will execute the instructions. So this is a video card, and if you want to play with some animations or games, you need good graphics. So the video card controls the information you see on the monitor. So if you install a good graphics driver, your system will look better with better graphics, right? So a video card will look like this, as shown in the slide. So you can attach without video card also, your computer will work fine. But if you want a better graphics, better visualization of all this HD quality and many other parameters, you can install a video card. Likewise, there is a sound card as well. So it generates complex sounds. It enables the PC to generate the complex sounds. A sound card will look like this. Okay. So these are the various hardware components that we can think of. And also we have modem, network card. The modem will come in two ways. One is portable Wi-Fi modem. So you can plug and play. So these are the recent, not recent, they've been there for a decade. So you can connect simply, and you can put a SIM card inside this, it will give you data, or you can connect a router. Router is also considered as one type of modem. Inside that you will get a LAN connection, or in your homes you would have observed many of you will have Wi-Fi connection. If you have Wi-Fi connection, that will come via router. Okay. So this will allow you to have internet access. So to work, to connect to the network or to work on the internet. So this will help you to connect your computer to connect with network or internet. These devices we need. Right. So let us see. These are all about system unit. So let us see some input devices. So any peripheral or a piece of computer hardware used to provide data or control the signals to the computer, we call that as input device, right? So for example, whatever the user is trying to put some data into the computer, we call them as input device. For example, when you're trying to type something, you are giving some data to the computer, right? So the keyboard will help you to write some letters or do something. The keyboard is an input device. The mouse, you are trying to control. See, I'm trying to move a laser point for presenting, and I typed this letter, so I use keyboard. This is an input device. The mouse which I am using now to present the class, or using laser pointer, which is an input device, I'm trying to do something. This is a mouse, and touch screen, scanner, webcam, all these are input devices. Okay. So a keyboard and mouse will look like this. No need to tell you. The scanner will help you to scan the files and documents or photographs, whatever you name it. So this is a scanner. And the touch screen, you are giving some sense by touching the screen, saying that I want a particular application to open or not. In your all mobile phones, the smartphones, all the smartphones will come with touch screen, which is also you are trying to do something by touching, which is an input device. Okay, so these are all a few input devices. Likewise, there are a few output devices. Any piece of computer hardware equipment used to communicate the results after data processing carried about by a computer to the outside world. So I am trying to move my mouse, but I am able to see in a monitor. Okay, you are able to see the monitor, you are able to see in your respective screens. So the monitor is an output device, the printer is an output device, the speakers, the sound is coming when I play music, when I play some song, when I play a movie, which is an output device, a projector which I am trying to display. These are all are few examples of output devices. Okay, so monitor which we are able to see the screen which I am projecting now, or which you are able to see from your perspective, from your laptop screen or desktop screen or mobile screen. They are all output devices. Likewise, the printer, projector, speakers, they are all output devices. Likewise, there are storage devices. So the components, devices that will record the data or record the media to store or capable of storing the data. We call that as the storage devices. There are various storage devices. You got floppy disk, hard disk, pen drive, and optical disk. Floppy disk was the outdated storage device. In earlier days, the storage device which we used to carry out is floppy disk, and the capacity is just 1.44 MB. So you might have aware what is MB is. It's a megabytes. It's very less. The capacity is very less. It is portable. A floppy disk will look like this, and a floppy disk reader or writer will look like this, as shown in the slide. So you can insert this floppy disk inside, and you'll be able to store just 1.44 MB. So in olden days, like 20 years back, this was very much I mean, like it was very much revolution. Predominantly, they used to store documents, files, which are all very important. So it is portable and it requires, if you have to read some data in the floppy disk, you need this floppy disk reader or writer. So this is not, nobody is using this because the capacity is very less, and we need an extra device to read or write. Nowadays nobody is using that, but for just for your information, what is a floppy disk, I'm just telling you. Optical disk, you got three types in optical disk. You got CD, which is a capacity of 650 MB around, and DVD, which will come with 4.7 GB, and Blu-ray disc, which will be coming around 20 up to 25 GB. This is also portable, but if you want to read or write, you need an optical disk drive. So optical disk drive will look like this, and this is the optical disk, and the device where it is kept is optical disk reader or writer or drive. So if you have seen in the previous slide, you got here a CD-ROM. The CD-ROM, you press this, the button will come outside to keep the CD or DVD or BD, Blu-ray disc. Okay, so depends on your various capacity. Nowadays, also few computers are coming with CD, DVD, ROM. You would have observed that. But still, although this is also helpful, they are also not used predominantly nowadays. Only when you submit your thesis, maybe they will ask you to buy a CD and burn all your data in the CD or DVD and submit to your department. Very less frequently they are used. Very seldom, means very less frequently they are used. And we all know that this is USB. Perhaps each one of you will have an individual USB drive. Will vary the capacity nowadays. Minimum it will come with 8 GB to 1 terabyte. Even you will have a capacity of USB flash drive with 1 TB, which is very portable. So we call that as USB flash drive. This is also one storage device which we all currently used. Which has been used by most of us nowadays, right? Everybody will have this USB flash drive. There are other storage devices that are discussed, like internal hard disk we discussed earlier. We got a capacity of 100 GB to 1 TB. This is not portable. You connect with motherboard. Wherever your system unit goes, your internal hard disk will go along with that. There is an external hard disk. You got a minimum from 1 TB to 16 TB also. You got an external hard disk will look like this, a simple plug and play, which is also portable. And you got other storage devices like cloud, Google Drive, Dropbox. So all this OneDrive where we use our MS Teams. I'll upload the slide. You'll be able to access from your respective phones or laptops. So this is all kind of cloud. So I'm storing my files in the cloud where others can access or take use of it. So instead of if I have to give this slide to each and everyone, I need to, suppose in your class there are 90 students, so I need to copy 90 times the files. Or if I send to one person, that one person may give to second person, then two persons to four to eight, and so on and so forth. But still, it's one to one. You have to copy every time. But the cloud will help you to just upload one time, but others can access if they are on the same platform. This will not cover. This is not part of your curriculum. But just when it comes to storage, nowadays predominantly many people are using cloud, where you can store and access or download at any time. So this is just for a brief idea. I gave you this detail, but ignore that. This is not, even if you are the cloud, there again you will have a mainframe computer. There again you will have storage, access and process. All these things will come. But you keep these two things in mind, like internal hard disk and external hard disk will be having a storage space. So in your mobile phones, we have a storage capacity. In your laptops, you will have internal hard disk capacity. And if it is not sufficient, you cannot connect to external hard disk as well. So these are the few things that we can know about hardware. So coming to software is a collection of programs The programs is a collection of instructions. A set of instructions is called a program. So but software is not only about programs. It's also a procedures and documentation that performs different tasks, right, on a computer system. So there are three examples of I can bring to your notice three examples of computer software: operating system, application software, and utility software. Before discussing this, if you have any doubts up to this point, you please let me know. Before up to hardware, if you have any doubts, please let me know. Okay, so I'll take that as no one has any doubts on these slides. So we'll have a brief overview of software, then we will stop. We'll start today's class. Maybe 10 minutes I'll take more, then we can stop. So as I told, the examples of computer software is an operating system. So operating system is not just a program or a procedure, but you need to have a documentation how the things will be performed inside the task. So you have application software and utility software. We'll try to see what they are. So a collection of software that manages computer hardware resources and provides common services for computer programs is what actually we can call an operating system. But this is a vague definition. This is not a correct definition. But the correct definition or more accurate definition I'll discuss in the next class. Okay. Once we study operating system in depth, we'll try to there is no standard definition for operating system, but we will try to understand what is a more accurate or closest definition, and we'll try to pin that. Okay, so for the time being, you can see that is a collection of operating system is a collection of software. It's not one software, it's multiple softwares that manages computer hardware resources. So you got many hardware resources, right? You got printer, you got hard disk, you got RAM, you got processor, you got camera, you got a lot of hardware devices that we discussed in the previous class. So who will manage all these aspects? Like when I move my mouse, it's an input device. You'll be able to see the monitor screen. Who's doing that? Who's doing on the behind screen? How my hardware is making work or making sense, that will be helpful for us. Like how my mouse or my monitor is working fine. What I'm trying to do is the processor is executing the PPT which I am sharing now. The browser, what we are sharing in MS Teams, that is also being executed in the processor. So there are a lot of hardware resources that has been encompassed, and the software handles it manages all the hardware resources and provides common services for the computer program. So the operating system does all these parameters, right? So the operating system is vital component of a system software in a computer system. So in a computer system, if there is no operating system, that will be very difficult for you to run an application. For example, in your first year programming, I don't know how many of you worked in Linux operating system. So when you run a program, you save with some file, you execute gcc space your file name .c, then you execute /a.out, and your code is converted into executable code. Who does that? How it will be converted? So without an operating system, how will interface? So what we are using now is a graphical user interface. So you can able to see the graphics PPT that will have different pictures, text, everything, right? So all these things is the hardware resources where how things will be done will be managed by operating system. And you have different types of operating systems. You got Windows operating system, you got Linux operating system, even your Android that you are using in your mobiles is also an operating system. Mac, predominantly Apple computers or Apple laptops or Apple phone iOS, which they use, is also a Mac OS. You got various types of operating system, depends on the user requirements and functionalities. We have different operating system. Right now I'm using Windows 10 operating system to project this slide. Right, you can see this. I will just show you this. So this is a Windows 10 operating system. How do I know that? So you can see in the computer, you can go to the properties. So you can see this Windows 10 Pro. So the edition what I am using is now Windows 10 Pro, right? So this is a 64-bit operating system. I will tell you what is the 64. So my GB is my RAM is 4 GB. I'm using i7 processor. Okay, i7 processor, Intel of type Intel. So these are the few things that you can notice. So all these things will be informed by your operating. You can see that a graphical user interface, how this Windows 10 operating system works like this. Likewise, there is an application software. An application software is an also known as application or the app, which is a computer software design to do a particular task. For example, I'm using this presentation PPT, which is a Microsoft PPT, right? So this is a Microsoft PowerPoint presentation, right? So where I can see that in help, if I go to okay, you can see the properties, show all the properties or options and accounts, many other parameters. You can see that this is a Microsoft PPT. But there are other ways also you can generate PPT. If you want to write some documents, you can write in Word, and you want to do some Excel sheet for data storage or manipulation. I will use Excel sheet or a graphics editor like Paint or Photoshop. So all these things is a specific application, and the software that are designed to provide such features called application software. Okay, and then utility software. So utility software is helped to design and configure or optimize and maintain a computer. For example, an antivirus, you got a defender or a firewall which has been defined, a disk defragmentation, disk cleaner, or a file manager. All these things, screensaver, all these things are utility software. So to protect your computer or to make your analyze what is happening, or to configure, or to, for example, I want to do some other for example, this is my hard disk. Like I got in C drive 75 GB and in my F drive 335 GB. Can I reallocate the space and create a new drive? Yes, it's possible. So you can go to disk defragmentation, which is in software provided. Disk defragmentation is one such feature that will help you to divide your disks into various categories. So you can see here the task scheduler, event scheduler, shared folders, storage, disk management. You got all this data, right? I got some amount of data unallocated. I got C drive this. So you can make a new partition. I can shrink this volume to, instead of 335 GB to maybe 150 GB, then 200 GB I can create a new partition. I can delete the volume and so on and so forth, right? So you can do many applications. You got Windows Defender. You can see here this Windows security actions recommended. So this is a part of operating system. This not exclusive, but the way they work is not exactly the operating system, but it works beyond that, right? So such kind of softwares are called utility software. So mainly like how to antivirus, which is not an application which is not an operating system, but still they will be helpful for us to make or analyze or configure if who's attacking or who's launching or how to maintain all these things will be considered as utility software. Does this make sense up to this? Does it make sense? Guys, are you there?
Yes, sir.
So you have any doubts so far?
No, sir.
No, sir.
Okay, so today's class is just a brief introduction, formal introduction. Many of you are aware of many things that we discussed today's class, but just to have an overview, we'll start with, because in subsequent classes, when I say input output devices, you should not be blank. What is input output devices? When I say what is a processor will execute or do something, when I say RAM, when I say secondary storage, you should not get any confusion. You should have a clarity. That's why we started from this. So we'll do a simple class exercise. I will show some pictures and you have to tell me what are the computer components are. Okay, a simple class exercise. Tell me, what is this?
So motherboard.
Motherboard.
Okay, this one.
Power supply, sir.
Power supply.
Good. This one.
So RAM.
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 Yeah, it's a RAM.
Processor.
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 This one.
Floppy disk.
Floppy disk.
Floppy disk.
Okay, so a simple class exercise to just verify whether you understood or not, whether you paid attention or not. So we'll stop the class now. We'll continue on Thursday. So if you have any doubts so far in this today's class, you please ask me.
Sir.
Yes.
So kindly share this PPT in on the group on MS Teams, sir, so that most of the students those who haven't joined the class can see.
Of course, I'll do that. I'll share after every class. I will share immediately the slides in your respective groups. So you can see that in your team, data structures and operating systems, there is a file called class materials. In the class materials, I will upload the slides.
Thank you, sir.
So I'll do that right now. You can verify whether you'll be able to see the slides or not. You can verify that. So I just uploaded a slide, lecture 1, basics of computers. Can you able to see the slide? You can verify.
Yes, sir. It's there.
Inside the class materials.
Yes, sir.
All right, so you can go through the slide, and if you have any doubts, you can ask me in the next class also. So we'll stop here and we'll meet on Thursday, 3 to 5.
Thank you, sir.
All right, you all can leave now.